Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, chapter 4.2, automobile transactions. The objectives for this lesson are to compute quartiles and interquartile ranges, create a frequency distribution from a set of data, and use box-and-whisker plots and stem-and-leaf plots to display information. Okay, there's a whole bunch of vocabulary here. Okay, I've listed all the vocabulary words from this chapter right here. All right, I am going to just go over them all down here. So the first one is data. Data is simply a set of numbers. Measures of central tendency, by definition, are single numbers such as the mean, median, and mode, designed to represent a typical, and the computer didn't recognize this when I converted it to a PDF. Those should be quotes, a typical value for the data, not question marks. Okay, quartiles. Three values represented by Q1, Q2, and Q3 that divide the distribution into four subsets that each contain 25% of the data. So if you're within quartile 1, you're below Q1, Q1 to Q2 is another quartile, Q2 to Q3 is a third, and then greater than Q3 is the fourth quartile. Lower quartile is Q1. It's the first quartile or lower quartile, and 25% of the numbers in the data set are at or below Q1. Upper quartile is Q3. Is the third quartile or upper quartile, and 75% of the numbers in the data set are at or below Q3. So 25% are above, okay? Subscripts, small numbers, similar to exponents, except in the descending position that are used to name quartiles. So these are all just caps, so it really should be Q sub 1 is what they mean. And I always just say that sub part. Q sub 1, Q sub 2, Q sub 3. Interquartile range is the difference between the upper and lower quartiles found by subtracting Q3 and, that's an ampersand, Q1. So in other words, Q3 minus Q1 equals the IQR, interquartile range. All right, stem and leaf plot. Now we're going way back. I don't know what grade this is done. I think 5th or 4th. This is elementary, my dear Watson, okay? A type of graph or data display that shows frequency numbers to the left of the vertical line. Stem represents the tens place digit. Numbers to the right of the vertical line. Leaf represent digits in the ones place in ascending order. We'll get into that in an example. Box and whisker plot, also called a box plot for short, is a type of graph that shows all four quartiles and the least number. It is drawn to scale. Okay, box plot, also called a box and whisker plot, a type of graph that shows all four quartiles and the least number. It should be drawn to scale. These are the same. So box and whisker plot also comes. I don't know. Anyway, and modified box plot, a special type of box plot that shows all the numbers that are outliers as single points past the whiskers. So let me just give you a quick example. If this were the body or our interquartile range, and this was our Q1, and this is our Q2 whisker, we would have like a dot or an asterisk out here representing outliers. That's a modified box plot. Okay, so there's the definition. So let's jump right into these examples, and here we go. Okay, example 1 says to find the quartiles for the tire pressures of car tires at an auto clinic. All right, so they gave us these tire pressures: 15 pounds per square inch, 17, 21, 25, 31, 32, 32, 32, 34. Tire pressure is measured in pounds per square inch, PSI. All right, so it says to find the quartiles. So we want quartile 1, quartile 2, and quartile 3. Quartile 2 is the first one that we start with. It is the median. How do we find the median? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data in our set. So when there's an odd number, the middle number is your median. When it's an even number, you take the two middle numbers and divide by 2. You take their average. So there is my Q2. It's 31. Okay. And then to find Q1, you take the median of the lower half. So the numbers, there are 4 numbers now. So like I said, when you have an even number, now I want to take the middle number of these 4, and that will be my Q1. And it is 17 plus 21, and we have to divide that by 2. In other words, it's the average. So that's going to be 38 divided by 2, which comes out to be 19. And then we do the same for the quartile 3, and that would be the median between 32 and 32. Now, when these two numbers are the same, there's no need to do it. It is just simply 32. I hope you all realize that 32 plus 32 is 64 divided by 2 is back to 32. So Q2 is 31. Q1 was 19. Q3 was 32. And Q4 is going to be the highest number. Okay, so then we go to Q4. I forgot my fourth Q, quartile 4. Q4 is the maximum, and that is just simply 34. Okay, so that's how you do your quartiles. Okay, find the median of the lower half, find the median of the upper half, and take the max for Q4. Now I'm going to show you how to do this in the calculator, because this actually could be helpful. So I'm going to turn my calculator on, and the first thing you do is you go to Stat, and you go to Edit, or just hit Enter. And we want to enter these values. Let me erase all these numbers here, all this stuff here, and go back to our values. Okay, so we want to enter those. So we go to Stat. Let me do that again. Clear, and you're on your home screen. First thing I would do is go to Y equals and make sure there's nothing there. Okay, and go to Stat, Enter, and I'll put these values in. So 15, enter, 17, enter, 21, enter, 25, 31, 32, 3 times, and 34. Okay, so always check when your cursor, or when you're highlighted your last value, it tells you what number that is in your set, and that there are 9. So there it is, all the data entered. Now we want to go to the stat plot, which is second Y equals, and we're going to hit Enter. First of all, we want to turn it on. And then we want to change the type. So I want to come down here. This is a dot plot and a line plot, and that's a bar graph or a histogram. This is actually, it's a bar graph. This with the outliers, if you remember the definition on the last page, that is a what? Modified box plot. And then this one is just the regular box plot. So we're going to go with that, and we're going to hit Enter. So then I'm going to hit graph. I'm just going to hit zoom 6 just to make sure it's 0 to 0. So you don't see anything. Zoom 6 isn't there. 19, 31, 32, 34 is way up over here somewhere. So you have to hit zoom, and I'll arrow down, but it's just 9. Zoom 9 is zoom stat. So I hit Enter, and there is my box plot. Okay, so it creates it for you. Now what's nice about that is once you put those values in and create your box plot, if you hit trace, it will tell you those values. The minimum is 15, Q1 is 19, Q2 is, or median, or the Q2 is 31, and it calls it the median. Q3 is 32, and Q4, or the max, is 34. Okay, so all those values are right there for you. It does all the calculations for you, and that is a box plot. So it says what percent of the numbers in a data set are above Q3. So think about that. Here's Q4, here's Q3. That is a quarter of the data. There is 25% of the data that is above Q3. So it'll be 25%. Okay, so that is the check your understanding. And let's move on. Okay, example 2 says, what is the difference between Q1 and Q3 in the data set in example 1? Okay, so what there's asking for when you say difference, you say Q3 minus Q1. So if I go back, Q3 was 32, Q1 was 19. So it's simply 32, not 33, 32 minus 19. And the difference between 32 and 19 is 13. So that is the inner quartile range. I should write that over here. Q3 minus Q1 equals the IQR. Okay, so if I went back to my calculator and traced, okay, there's 32 and there's 19. So they're saying that the range of this data goes from 19 to 32, and that's a range of 13. Okay, and that is IQR. Okay, check your understanding. Here we go. So let me just slide this up here so it's a little higher. And here's what we're going to do. It says to find the inner quartile range. Find the IQR. Well, the IQR is Q3 minus Q1. So I need Q1, I need Q2, I need Q3, and I need Q sub 4. Okay. Q sub 4 is the maximum, 38. Q sub 2 is the median. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces of data. The middle of 15 being odd is 7 on both sides, and the middle one is the median. 1, 2, 3, 4, 5, 6, 7. So this is 8. Having 7 over here, 23 is quartile 2 or the median. Then I look at the lower half, and there's 1, 2, 3, 4, 5, 6, 7. And so 1, 2, 3, 4 is the middle. Same with over here. 1, 2, 3, 4 is the middle. So Q1 is 15 and Q3 is 31. And the IQR equals Q3. Okay, Q3 minus Q1. So the IQR equals 31 minus 15, which is 16. And I'm now going to do that in the calculator. So you go to y equals, the plot is on, I've already set that all up. Go to y equals, let me go up and explain that again. I'll hit enter. Now it's off. So you can, that's another way you can turn it on, but it's better to go into stat plot here because you have to change it to this. Make sure it's on and make sure it's box plot. Now I'm going to go to stat, edit, arrow up to L1 and hit clear, and arrow down and they're gone. And now I'm going to enter these values right here. So it's 12, 12, 13, 15, 17, 20, 20, 23, 24 twice, 27, 31, 33, 34, and 38. And there are 15 data pieces. And now I'm going to hit y equals. I'm not y equals, I'm sorry. I'm going to hit graph. And I'm going to hit zoom 9 so I can see the whole thing. And there it is. So now then I hit trace, I could just simply have gone here and said, okay, Q3 is 31, and arrow over to, and Q1 is 15. So the inner quartile range is the difference of those two. Okay, so there you have it. Okay, example 3 says to find the outliers. Well, what are outliers? That was messy. Let me try that again. Outliers are simply 1.5 times the inner quartile range. Okay, so here's what we need to do. We need to find, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. So that's half of 9. There's 4 and 4, and then the one in the middle. So 1, 2, 3, 4. This is Q2. All right, so we don't know Q1 yet. Q2 is 146. We don't know Q3 yet. Q4 is the maximum, unless it's an outlier. Okay, so I'm not even going to address Q4 in this problem. I'm just going to leave it off. All right, but we need Q3 and Q1 because we want to find the inner quartile range. So to find Q1, that is going to equal the average of these two numbers. So it's going to be 88 plus 109 divided by 2. Okay, 9 and 8 is 17, carry the 1. 8 and 1 is 9, that is 197 divided by 2, which is 98.5. Okay, so Q1 is 98.5. I'm then going to find Q3, and Q3 is going to equal, okay, I should be changing colors here. So this was, we have to take the average of those two, we have to take the average of these two. Okay, so Q3 is going to be 202 plus 218 divided by 2. Okay, so 202 plus 218 is 420 divided by 2 is 210. Okay, kind of ran out of room there. 210, I'll put it down here. 210 is Q3. Okay, the inner quartile range is then IQR equals Q3. And I would highly recommend writing these every single time. It helps you remember what all these things are. So IQR is Q3 210 minus 98.5. So the inner quartile range equals, and when I take 210 minus 98.5, I get 111.5. Okay, so that's our inner quartile range. So to compute boundaries for the lower outlier, so for the lower outlier, we need to take the inner quartile range of 111.5, and we're going to multiply that by 1.5. We take 1.5 times the inner quartile range, and we subtract it from 98.5, which was the quarter Q1. So we take Q1 minus the inner quartile range times 1.5. Okay, so 98 minus 1.5 times 111.5. Okay, so let me just use the calculator to speed this up. Okay, so what do we have? 98 minus 1.5 times 111.5. And when I do that, I get negative 69.25. Is that right? 98. Oops, it's 98.5. Let me do that again. 98.5 Q1 minus 1.5 times the inner quartile range, 111.5. I hit enter and I get negative 68.75. Negative. Okay. Obviously, we're not going to have negative dollars. Hang on, my dog's going crazy. Okay, dogs went crazy when dogs walked by, so sorry about that. So 98 minus 1.5 times 111.5 is negative 68.75. You can't have a negative dollar amount. There will not be any lower outliers. Now for the upper, we do the same thing, except we take the Q3 210 plus 1.5 times the inner quartile range. So then I get my calculator out and do 210 plus 1.5 times 111.5, and I get $377.25. So there's the upper outlier range. So anything above 377.25 is an upper outlier. 218 is not more, but 545 is. So whatever that tire is, it is definitely way more expensive than 1.5 times the inner quartile range. So the outlier, there's only one in this case, it is $545. Okay, so that's how you do outliers. Now check your understanding. It says the store charged $545 for a tire. Yep, that one right there. In example 3, and they had a sale and lowered its price to $399. Is the new price an upper outlier? Well, it's more than $377.25 even on sale. So the answer is yes, it is still an outlier. Okay, that's that. Okay, example 4. It says Rod was doing internet research on the number of gasoline price changes per year in gas stations in his county. He found the following graph called a stem-and-leaf plot. What are the mean and the median of this distribution? Okay, so I'm going to do the mean first, or the median, I mean. Let me do the median first. And what you have to do is count how many there are and then go halfway in. So there's this one out here is the stem. These are the stems and these are the leaves. So they give you an example. They say, okay, down here in the legend, 5 is the stem, 2 is the leaf, and 5 with the 2 over here is the number 52. So this is 11, 11, 12, 13, 17, 19, 20, 23, etc. Okay, so there's 1, 2, 3, 4, 5, 6 in the 10s. There's 1, 2, 3, 4 in the 20s. There's 1, 2, 3, 4, 5, 6, 7 in the 30s, 1 in the 40s, 8 in the 50s, 3 in the 60s, and 1 in the 70s. And 6 and 4 is 10, and 7 is 17, 18, 26, 29, 30. There are a total of 30 numbers in this set. So I'm going to count in to 15, and the 2 middle numbers, since this is even, will be the average of those 2 will be our median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 are right here. So if I counted backwards, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 are the same 2 numbers. So to find the median, when you have an even set of data, you take the 2 numbers, which is not necessary when they're equal, because obviously this is going to come out to be the same. And you take 9 plus 9 divided by 2, which is 18 divided by 2, which is 9. So the median was 9. Well, it's not 9. You have to look over here and put your stem in, and it is 39. Okay, so the median was 39. Now we have to work on finding the mean. All right, so the mean is the average. So I'm going to get my calculator, and I'm just going to enter these in the calculator. So it's going to be 11 plus 11 plus 12 plus 13 plus 17 plus 19. Okay, that's the first row. I'm just going to hit enter here. So that's totals 83. And then I'm going to hit plus, and I'm going to do 20 plus 23 plus 26 twice and hit enter. So I'm going to, whoops, backspace, wrong button. How about this? And I'm going to delete that and hit enter. Now we're up to 178, and now we're going to do plus 40. Oh, we skipped the 30s. So let me go back here, and it's 38 plus 38 plus 39 plus 39 plus 39 plus 39 plus 39. Enter. Plus 40. Enter. We're up to 489 plus 52 twice. 54. 55 3 times. 56 and 57. Enter. We're up to 925 plus 63 plus 64 plus 64. Enter. Plus 72, and that is our total, 1,188. So my mean is going to equal the sum of all these numbers, which was 1,188. And we're going to divide that by the number of data entry points of 30. So then I go back here and I hit divided by 30 and I hit enter, and I got the mean to equal 39.6. So as you can see, the mean and the median, that's a very neat. The mean and the median are both 39, roughly. Okay. Now it says find the range in the upper and lower quartiles in example 3. Okay. So in order to find the range, let me just move this up here. Find the range in the upper and lower quartiles in example 3. Okay. The range is the highest number, 72. So I'm going to say range equals 72 minus the lower 11, which equals 61. Okay, so there's the range. And we want upper and lower quartiles. So Q1, we already know Q2 is our median, 39. Q3. So now that we know this is our median 39, it's right here in the middle. We have 1, 2, 3, we had 15 on each side. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, it's 23. Q1 is 23. Do the same on the other side. 1, 2, 3, 4, 5, 6, 7, 8. Just check and make sure. 1, 2, 3, 4, 5, 6, 7, 8. And Q3 is 55. Okay, so the range was 61. Quartile 1, which is the lower quartile, is 23. And the upper quartile, Q3, is 55. Okay, example 5. Rod, who was researching gas prices, in example 4, found another graph called a box and whisker plot, or simply box plot. It is shown below. Find the inner quartile range of the distribution. So this 11 here is a minimum. This 72 is the maximum, or Q4. This 55 is Q3. This 23 is Q1, and 39 is the median, or Q2. To find the IQR from a box and whisker plot, you simply take Q3 minus Q1, and this is Q1 here. This is Q3. I'll just label them all. Let me change colors for the ones I'm not going to use. This is Q2, also called the median. Okay, and this is Q4, also called the maximum. And this is the minimum. Okay, Q1, Q2, Q3, Q4, max, median, min. So the inner quartile range is what this is asking for, is just simply asking us to take Q3, which is 55, minus 23. And that's going to equal 5 minus 3 is 2, 5 minus 2 is 3. So the inner quartile range is 32. Okay, the check your understanding is asking, based on the box and whisker plot from example 4, what percent of the gas stations has 55 or fewer price changes? Okay, so here is 55. 55 or fewer is this direction, and this is 25%. This is 25%. This is 25%. And this is 25%. So 55 or fewer is these three, which is 75%. All right, example 6 says the following box and whisker plot gives the purchase prices of cars of 114 seniors at West High School. Are any of the car prices outliers? That is all they're asking. Are there any outliers? And let me use purple this time. An outlier is the interquartile range times 1.5, anything above Q1 or Q3, or anything below Q1 from that value. So first thing I'm going to do is just say VIQR equals Q3 minus Q1, which equals Q3, which is right here, $9,100, not 91,000, $9,100 minus Q1, $5,200. 9,100 minus 5,200 is 0, 0, 9, 3. So 3,900 is the interquartile range. And then you take that interquartile range, 3,900, multiply it by 1.5. And just to save time, I'll do it this way. 3,900 times 1.5 is 5,850. Okay, so that's our interquartile range times the 1.5. So then we take that 5,850 and take Q1 minus that. So I'm going to do the lower half. So it's going to be Q1 minus that. So I'll write that Q1 minus 1.5 IQR. Okay, which is going to be Q1, which is 5,200, 5,200 minus 1.5 the IQR, which was $5,850. That's going to come out to be a negative number. So I don't really need to continue, but I will put it down. As soon as you see that it's negative, you know it can't happen because nobody pays you to take their car. All right, cars aren't free or less than or more than free, cheaper than free, I should say. All right, so now let's check to see if there's upper quartile or outliers on the upper end. And it looks like there is. This out here, it looks pretty long, this quarter here. So I'm going to take Q3 plus 1.5 times the IQR. Okay, I should probably have these in parentheses to show its multiplication. Q3 is $9,100 plus this $5,850. And when I add those, 0 plus 0 is 0, 0 plus 5 is 5, 1 plus 8 is 9, and 9 plus 5 is 14. So anything above 14,950 is an outlier. So we don't know how many values are in here, but there is at least one outlier because Q4 or the maximum was $43,000. So yes, there are outliers on the upper end, no outliers on the lower because that can't happen. Okay, so now let's look at check your understanding, and it says examine the modified box plot. Notice it says modified, meaning there are outliers. Here's one and there's 4 up here. Is 400 an outlier? Okay, so 600 is the maximum, 510 is the minimum. So somewhere in between is these values, and it's, remember that each one is 25% of the data. So 510, here's X, here's Y, here's W. 400 is less than 510. So I'm assuming that maybe that's that right there. So we don't even need to have to calculate anything here. 400, looking at this, if 400 is below this whisker of 510, Q1 is right here, 400 is below that. And therefore, and these 4 values are above this 600, which is Q4. So those are outliers. So is there an outlier? Is 400 an outlier? The answer is yes. Okay. It's less than 510. Okay, so I believe that is the end of this lesson. So that's the end of chapter 4.2. Have a great day. Thanks for watching. And again, peace.